Hi everyone. So this is the second video for chapter 6 heat transfer for class 8 physics for St. Thomas School, Ranchi. So under this chapter or under this topic or this video we are going to see the topic change in dimension. So means that here we are going to see what is going to happen to any material when heat energy is going to supply to it. So when heat energy is going to supply to any material, it is going to expand. And this property of a matter is called as thermal expansion. Thermal expansion in solid is of three types: linear expansion, superficial expansion, and cubical expansion. So next we are going to see what is linear expansion. So the increase in the length of a solid when it is heated is called linear expansion. So this means that when heat energy is supplied to any solid and if its length is going to increase, then it is called as linear expansion, and it is represented by delta L, which is equal to alpha capital L into delta T. So here this delta L is going to represent change in a length of a solid material. Alpha represents coefficient of linear expansion. Capital L is going to represent its original length and delta T is going to represent change in temperature. So this means that when we want to find out how much length is going to increase when heat energy is supplied to any solid material, which is represented by delta L, we can able to find out by multiplying alpha, coefficient of linear expansion, L, its original length, and delta T means that what is the change in temperature when heat energy is supplied to that solid material. So next we are going to see what is superficial expansion. So increase in area of solid when heat is supplied to it, it is called superficial expansion, and it is given by the expression delta S is equal to beta. So this is beta, then capital S, which is representing its original area, and delta T, which is going to represent change in temperature of that solid material when heat energy is going to supply. Then next we are going to see what is cubical expansion. So increase in the volume of a solid when it is heated, it is called as cubical expansion. So means that when heat energy is supplied to any solid material and if its volume is going to increase, then it is called as cubical expansion, and it is represented with delta V, which is equal to gamma. So this is gamma, which is going to represent coefficient of cubical expansion, and this is capital V, which represents original volume of that solid material, and delta T is going to represent change in temperature. Next we are going to see how the thermal expansion is going to occur in a case of liquid material. So in a case of liquid, when heat energy is going to supply, what is going to happen? Its average kinetic energy is going to increase. And because of that, what is going to happen? Its intermolecular space is going to increase, which is going to result in thermal expansion. And here point to be noted that always in a case of liquid expansion, a type of expansion which is going to take place, it is cubical expansion, means that expansion is going to take place in overall volume of a liquid when heat energy is supplied to it. For an example, to observe that how thermal expansion occurs in a liquid, first example here it is given that thermal expansion principle uses in thermometer. So means that, as we all know, that when heat energy is applied to mercury, which is in thermometer, the mercury expands. Second is, it is recommended not to fill fuel tank to the top in summer, because in a summer season, when heat energy from the surrounding is going to supply to the fuel tank, the fuel is going to expand and then it will create explosion. Third example is, water or steam pipes are given a U bend. So by making a pipes U bend, we are going to save it from any kind of damage when thermal expansion in liquid is going to occur. So next we are going to see thermal expansion in gas. So in a gas also, the expansion which is going to take place, it is a cubical expansion. And in a case of gas, thermal expansion is more as compared to solid and liquid. Why it is more? Because average kinetic energy of the molecules in a gas increases vigorously, and thus the intermolecular space increases. Thus, in case of gas, the thermal expansion occurs more significant than solid and liquid. And here in a diagram, we can observe that, so this is the balloon which is filled with the air, and inside the glass tumbler the air particles are present, and it is going to heated, it is put on a water and it is going to get heated. So when a water is going to get heated, the air which is going to present in this glass tumbler, it is also going to get heated and it is going to expand. And when this gas particle is going to expand, the balloon is also going to increase its volume, so which represents thermal expansion in gas. Thank you.